Okay, guys, this is your P2, P3, and P6 test review. The first four questions are asking you to write your answer with a rational exponent. That means a fraction. So remember, this is 7 to the first power, so my index of 3 becomes the denominator, and I would rewrite this as 7 to the 1/3. And B, 5 becomes the denominator of my fraction, so it'd be 7 to the 4/5. And 36, 3 becomes my denominator, and I have 5 to the 7/3. In B, they're telling us to take this fourth root and cube it. So you're going to multiply it by itself 3 times. And we've talked about this before. A house times a house is just a bigger house. So I have the fourth root. And when I multiply 5 times 5 times 5, I get 125. And that's the first power. So then I would bring the 4 here. It would become my denominator, and I'd have 125 to the 1/4 power. In 37a, my 6, the index of 6, becomes the denominator of my fraction. So I have x to the 5/6. Here I have the square root of 9. Sorry, the square root of x multiplied by itself 9 times just becomes 1, 2, 3, 4, 5, 6, 7, 8, and 9. So what this really gives me, look, if you square a square root, this becomes just x. If you square a square root, it becomes x, or x times x, x. So I have x to the 4th, and then I have a square root of x left inside. Again, there's a little 2 here, so that becomes my denominator. I have y to the 3/2. And then here I have square root of 8, or not square root of 8, the 8th root of y. So I have the 8th root of y squared, so the 8th root of y. A root times root is just a bigger root, so I have the 8th root of y squared. And then if I write that with a fractional exponent, I have y to the 2/8, which becomes y to the 1/4. Up here, I'd have to rewrite this, I'm sorry, as x to the 4th, and then this would be an x to the 1/2. All right, in 39, we have to use all of our properties of exponents. So the first thing I'm going to do is look, and I'm going to say, okay, this squared outside of my parentheses goes to everything inside. So this becomes 2 squared, which is 4. X to the 3rd squared would be x to the 6th. We multiply our powers, y squared. And then I have my second parenthesis of 3x to the negative 1, y squared. And now we just simplify. Multiply the numbers. 3 times 4 is 12. I have x times x, so same base, and I have same base that I'm multiplying. I'm going to add the exponents, so 6 and negative 1 gives me 5. And then I have y's, same base, so I add the exponent, so 2 plus 2 is 4. In this next one, again, we're going to distribute our exponent to everything inside of the parentheses. So I have a to the negative 6, and then I have a to the 6th, b to the 2nd, and then b to the 12th. So when you multiply same bases, you add exponents. So I have a, negative 6 plus 6 is 0, and then I have b, 12 plus 2 is 14. A to the 0 is 1, so you just are left with b to the 14th. In 41, again, we're going to distribute our exponent to everything inside of the parentheses. So I have x to the 4th, 3 squared is 9, x squared over x to the 3rd. So let's simplify in the numerator. I have my 9. I have this base of x being multiplied, so I add exponents. 4 plus 2 is 6 over x to the 3rd. And then when we divide bases that are the same, I have 9, and then 6 minus 3 gives me x cubed. In 42, again, distribute. So I distribute to every single thing inside of my parenthesis. So I have r to the 12th, s to the 6 times 4 is 24 over 3, which we can simplify here in a second. and then I have r to the 6 over 3, s to the 6th. So this leaves me with r to the 12th, s to the 8th, over r squared, s to the 6th. And now we can simplify. If I have the same bases and I'm dividing them, then I'm going to subtract exponents. So that gives me r to the 10th, s to the 2nd. In this case, we're going to distribute on 43, distribute first. So it goes here and here. So you have the cube root of x to the 6th, y squared, y to the 4th. So we're still going to continue to simplify underneath. So I have x to the 6th, y times y. You add exponents is y to the 6th. This is the same thing as saying, if I change this, bring this denominator over here, I have x to the 6 over 3, y to the 6 over 3, which would be x squared, y squared. You could also write out your x's and y's underneath and take out groups if you wanted to. Same thing here. This is a 2, so if I rewrite this as a rational exponent, I have x to the 2 over 2, y to the 4 over 2, which gives me x to the first, y to the second. Again, you could write out 2 x's and 4 y's and then take out pairs. In this case here, where there's no powers that we need to distribute, so we're just going to go through and simplify. 8 divided by 2 gives me 4. I have r to the 1/2, r to the negative 2, s to the negative 3, s to the 4th. I'm going to make my exponents positive first before I start adding and subtracting. So I'm going to move r to the 2nd up top, so that becomes r to the 2nd, and then r to the 1/2. And then I move my s to the negative 3 to the bottom to make it positive. So now I'm going to simplify my exponents. If I have the same base and I add exponents, this would be the same as 4 over 2. So it's 4 r to the 5 over 2, and then s to the 7th. You add your exponents there. All right, 46, we're going to just distribute. This negative 2 goes to every single term, every single thing that's inside of this exponent, inside of the parentheses. So I have in the numerator a to the negative 2, b to the negative 4, we're multiplying, and then c to the 6th. Then I have 2 to the negative 2, a to the negative 4, and b to the 8th. Now, before I do anything with my adding and subtracting of exponents, I'm going to move them so they become positive. If they're negative exponents in the numerator, we're going to move them down. If they're negative exponents in the denominator, we're going to move them up. So 2 squared comes up here. My a squared on top, I'm going to move it down. So a squared goes down. My a to the 4th, on the bottom, I'm going to move it up to be positive. b to the 4th, I'm going to move down. And b to the 8th. And then c is going to stay up here. So when I simplify this, 2 squared is 4. And then if I have the same bases and we're dividing, we're going to subtract exponents. So this becomes a squared, c to the 6th, over, add your exponents of 4 and 8, and you get 12. When we get down here, we're going to start factoring. And we have to remember the first thing you look for in your factoring is GCF. Always, always, always look for a GCF. And then we'll worry about difference of perfect squares and all that good stuff. But for 51, greatest common factor, what can you take out of 2x and y here? I can take out a 2, I can take out 1x, and I can take out 1y. So I'm going to take it out of both. Now, when you take this out, when you take your GCF out, your GCF comes out in front and you leave it there. You do not don't ever look at it again and not write it. You have to have it out in front of your parentheses. So this becomes, I'm left with x squared divided by x gives me x. My y's cancel out. Then I have negative 3. My x's will cancel out, and y. And that's it. There's nothing else I can do. There's no difference of perfect squares or anything like that. So we're done. In the next one, look and see what you can take out. Well, I can take a 3 out of all 3 of these terms. I can take at least one x out of all 3, and I can take at least 2 y's out. So 3xy squared, 3xy squared. So when I do that, ladies and gents, watch. My 3xy squared is out in front, 3xy squared. I write that out in front, and then I do my simplifying. So I say 12 divided by 3 is 4. X squared divided by x gives me x, and I'm left with y squared, because 4 minus 2. So now I divide. My x's divide out, so I'm left with plus y cubed. 9 divided by 3 is 3. X cubed divided by x gives me x squared, and my y's will cancel out. And that's it. There's nothing else you can do. You are simplified. Now we're going to get to factoring our trinomials. Very basic. You guys have seen this a bunch. You guys can handle this. When I look at this, I say to myself, okay, well, what can I take out of any, what is the GCF? There is not one. So now I say, all right, well, a times c, 1 times negative 14. What are the factors of negative 14 that multiply to give me negative 14 and add to give me 5? So I have 1 and 14, 2 and 7. Well, 2 and 7 will be my combo. So I have x and x. I want a positive 5, so I want plus 7 and minus 2. And there you're factored. If you want to check, you can FOIL that back out, and you should get your original answer. Okay, same thing on the next one. Instead of x squared, I have x to the fourth. That just means I have x squared in both parentheses. What are the factors of 2 that multiply to give me negative 2 but add to give me 1? Well, that would be plus 2 and minus 1. Now I have to say, okay, am I completely factored? X squared plus 2 does not factor anymore. That's it. But is x squared minus 1 the difference of perfect squares? And yes, it is. X times x gives me x squared. And then I have minus 1 plus 1. So you always have to check when you have a binomial, check to see if it's the difference of perfect squares, if you can make it any smaller. Now in 55, we're factoring where a is not 1. So I'm going to say 3 times negative 1 is negative 3. What are the factors of negative 3 that multiply to give me negative 3, but add to give me negative 2? And that would obviously be, excuse me, obviously be 3 and 1. So I have x and x, and then I'm going to have a minus 3 and a positive 1. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. Now, since my a term is not 1, I have to put that underneath both factors. 3 divided by 3 simplifies to 1, so it's x minus 1. 1 divided by 3 does not simplify, so my 3 comes out in front, and I have 3x plus 1. Again, you can FOIL that out, and you'll get your original. In 56, again, guys, first thing we ask is GCF. Is there a greatest common factor? Is there a GCF in this? No. So now I'm going to say, okay, fine. I have to multiply a times c. So 6 times negative 12 is negative 72. What are the factors of 72 that will multiply to give me negative 72, but add to give me 1? And that would be 8 and 9. So x and x, I'm going to say positive 9 and negative 8. And since my a term is not 1, I put it underneath and I simplify. So this becomes x plus 3 over 2. And this becomes x minus 4 over 3. Neither of those simplify to anything pretty, so we bring it out in front, and I have 2x plus 3, and then I have 3x minus 4. Now again, you can FOIL that back out, and you should get your original. For 57, I'm going to change my t's to x's just because I don't like what happens when I write them. When I write t's, they look like plus signs. So again, no GCF, so I'm going to multiply a times c. 4 times negative 12 is negative 48. Factors of negative 48 that multiply to give me negative 48, but add to give me negative 13. That would be 6 and 3. So x and x, 16, I'm sorry, and 3. So minus 16 plus 3. Our a term is not 1. So I bring that out in front. I put it underneath. 16 divided by 4 gives me 4. So x minus 4. And then 3 divided by 4 doesn't come out pretty. So I have 3x. So I have 4 comes out in front, 4x plus 3. And again, you can factor that, FOIL that back out, and you'll get your answer. Okay, we're looking here, x to the fourth. What's going to give me x to the fourth? Well, that would be x squared times x squared. What are the factors of 1 that multiply to give me 1, but add to give me negative 2? That would be a negative 1 and a negative 1. And now you guys are going to say, oh, okay, good, I'm done. Well, actually, is this the difference of perfect squares? And it is. So this becomes x plus 1, x minus 1, x plus 1, and x minus 1. Okay, so now we look at 59 and we say 59, all right, is there a GCF? Can I take a GCF out of 16 and 4? And you can. I'm going to take a 4 out. So I have 4 out in front, and I'm left with 4 minus t squared. Now we say, all right, I have a binomial. Is this the difference of perfect squares? And yes, it is. So I have 4 times 2 plus t and t minus, or 2 minus t. There's our difference of perfect squares. All right, 60. GCF. Is there a GCF in 60? Yes, I can take out 2y squared from both of those. So when I do that, I have 2y squared out in front. 2 divided by 2, I get inside y to the 4th. 32 divided by 2 is 16, so minus 16. Can I simplify any more? Yes, you can. Difference of perfect squares. So 2y squared, and then I'm left with y squared plus 4, y squared minus 4. And now we say, well, wait, can I simplify even more? Yes, you can. You have 2y squared. Y squared plus 4 will not break down any, but this is the difference of perfect squares. So y plus 2, y minus 2. Always, 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 guys, when you have a binomial, you have to look and see, is this the difference of perfect squares? All right, 65. GCF. Is there a GCF? No. Is this a trinomial? No. Is this a binomial, difference of perfect squares? No. We are going to factor this one by grouping because I have 4 terms. So I'm going to take the first 2 and the second 2. What can I take out of 4x cubed minus 8x squared? Well, I could take a 4x squared, and I would be left with x minus 2. Now in the second parenthesis, I can take out a 3. Positive 3 is what I'm taking out, and I'm left with x minus 2. So now I notice that I have the same parenthesis, so I'm going to write it one time out in front, just once, x minus 2, and then whatever's left over gets its own parenthesis. So we have 4x squared plus 3. And I look and I say, is this the difference of perfect squares or anything? It's not, so you are done. You don't have to do anything else. Again, 4 terms again. There's no GCF, so factor by grouping. I'm going to take out an x squared. I'm left with 3x minus 2. In the second parenthesis, I can take out a 6. Yep, I can take out a 6. So plus 6. 18 divided by 6 would be 3x and then minus 2. If you guys notice, we got our same parenthesis. So we write that out in front one time. And then whatever is left over gets its own parenthesis. So you have x squared plus 6. And that is not difference of perfect squares or anything, so you're good. 67 and 68. The way that I would tell you guys to do this is I would rewrite this problem. I have x plus y squared minus 7 times x plus y plus 6. You can look at this as saying that this whole expression could just be an x. Because if you factor this, if I rewrote this as x squared minus 7x plus 6, you guys would say, oh, I can factor that easily. What times what? It's going to give me a positive 6 when I multiply, but a negative 7 when I add. That would be x minus 6 and x minus 1. Now just replace that x with whatever this expression is. So I'm going to say x plus y minus 6 and x plus y minus 1. And that's factored. Same thing you can do here on 68. I'm going to rewrite 68. I'm going to replace the a and the b for a second just with the letter x. So this would be x squared minus 3x minus 10. So what are the factors of negative 10 that multiply to give me negative 10, but add to give me negative 3? It'd be negative 5 and positive 2. And now I'm going to replace the x value. I'm going to replace this x value with the expression a plus b. So it would be a plus b minus 5 and a plus b plus 2. And that's it. We skip these ones because this is the sum of difference of cubes, and we are not including that on this test. We haven't even talked about it, so don't worry about it. So guys, if you have questions, you need to email me this weekend and jump on that Zoom call at 3 o'clock on Monday so we can go over anything that you might have last minute questions. Have a great weekend, and I'll see you guys on Monday or Tuesday. Bye.